The variance is another way to measure variation, and in this case it takes into consideration all the data. For example, suppose this is the data I have 6 values here. Remember the range, which is the first measure of variation, only consider the minimum value and the maximum value. 8 minus 0 is 8. But the variance consider all the data. So here we get the distance between every value and the mean, the average. The average is simply to add them all and divide by 6, their number. So we need to get the distance between every value and the average. If we use the value minus average, sometimes the distance will be negative, and the positive values will be cancelled by the negative values, and we don't want this to happen. We want all the distances to be positive. So one way to do that is to square the distance. So that means we take every value and subtract the mean, the average, and then we square it to make sure it's positive. And then we get the average of the square distance. So that's how the formula should look like. It is the average of the square distance between every value and the mean. X is a value of any particular variable, and mu is the mean. And for every value, if you subtract and then square, and then you will have the square distances in this case, and then you should get the average. And as you know, to get the average, we add them all and divide by n, the data size. So maybe an example will make the formula more clear. In our example, we get the average first, where we add all the values and then divide by 6, which is how many they are. And in this case, the mu, the average, the mean is 4. And then we get the distance between every value and the mean. So here is all the values, and here is every value subtracting the mean. So here 3 minus 4 is minus 1. And then 8 minus 4 is 4, and then 4 minus 4 is 0, 7 minus 4 is 3, 0 minus 4 is minus 4, and 2, which is the last value in my data, minus 4, which is the mean, that gives you minus 2. So here I got the distances, x minus mu, every value x minus mu. Now, the next step is to square them and make them all to make them all positive. So minus 1 when you square it will become 1, 4 when you square it becomes 16, and so on. Now I get the average of these square distances by adding them all, and then I divide by 6, which is the data size. So 46 over 6 give you approximately 7.666, which means if you've rounded to one decimal place, because the data here are integers, then it would be 7.7. So again, this seems to be a compact formula. And the sum of the square distances divided by the data size. You need to memorize this formula because it will not be provided in the exam formula sheet. But why it will not be provided in the exam formula sheet? Because is usually not encouraged to use this formula. There is one problem with this formula, that students sometimes make mistake when they apply it. If the mean here is a decimal number, then if it's a large number like this maybe, then you round it. Most probably students round this number, and when they get the difference here, the difference will be not really accurate enough. And when they get the sum, it will not be accurate enough. And then when you get the variance, it's not going to be accurate enough. And that's the problem here of this formula. You must calculate the mean first in order to use the formula. So that's why there is another formula that is exactly bring the same results, just like this one, but without the needful calculation of the mean. And that's why we can avoid the rounding error that comes from the mean. So let us have a look at what could be this other practical formula that will actually come in the formula sheet in the exam.